Hello everyone, welcome back to lesson number 17, where we're talking about different integration techniques for BC Calculus. And before we get into more problems, I would like to first of all introduce to you guys two new concepts that we're going to use for other integration techniques that we're going to do in the next video. So this video is just going to basically talk about how to integrate these two functions and functions very similar to it. So let me just talk about this first one for a second and look at that. This one is going to be typically a number over the square root of some number minus some function squared. All right, that's really the idea behind this right here. There are some times where you have variables up here, which we'll get to much later in the course, but just this is a general simplistic question that shows you a basic way of how to integrate this. So it's going to be some number, it can be positive or negative, all over the square root of, again, some number minus a function squared. All right, so this exponent is going to be even. When you do this, now sometimes guys, I'm always telling you, U sub is going to be a good tool here. You want to always try U sub, but if you do U sub here, you're going to get 9. If you make U equal to 9 minus 25x squared, your derivative is going to be negative 50x. Well, you don't have an x up here. If this had been 1x, then U sub is how you do this problem. But again, I'm trying to go very basic here with this, so U sub doesn't work. Well, what I want you guys to look at here is what if this had just, let's make everything a 1 for a second. Let's make all the constants 1s for 1 second. So if we look at this as a, and again, these are not equal, just to kind of think visually what we need to do here. If I just make this all 1, right, if I make all my constants 1 for a second, what is this? Well, you guys already know what this is. This is the arc sine of x. So we know we're looking at an arc sine function here. Right, we do have some numbers that we have to take care of, but we're looking at this function. So that's really powerful to know that when you have 1 over. So when you're looking at integrations, you want a fraction, you need to have a square root in the denominator, and you need to have a number minus a function squared. Okay, now again, if you have a variable or some function at the top, maybe try U substitution first, because that may be the right way to do it. But now that we know that it's arc sine, here is what I do. This is how I teach it, and this is hopefully the way you guys understand it. So I'm going to go ahead, just like before, I'm going to do a U squared, and the U is going to always be the function. All right, U is going to always be the function. So it's going to be what's after the negative. All right, what's after the negative. So U squared is going to be 25x squared. Okay, 25x squared. The A squared, A is going to be the number. And just these are arbitrary letters that we just typically, when we're doing the formulas, and I'm going to write up the formula for you guys in a minute. We just choose U, again, because U sub, we like that. And then A, we just make it because it's the closest, I think, to the numbers. So this is going to be our U squared, and this is going to be our A squared. All right. So then we're going to take the square root of this. We want to get U, so we're going to get 5x. By the way, it doesn't matter if these are perfect squares. So if this had been 7, then it would just be the square root of 7 times x. All right. So don't think that it can't be right if these are not perfect squares. It's just a number minus the function squared. Right. Okay. And then just like before, and this, I'm going to put this in a different color. You always want to make once you write U, you always will do a du. So you always need to do 5 dx. All right. And that's super, super, super important. Now, we've actually done all the work that we need to actually solve this problem. Since we now understand that this is going to be an arc sine, all we have to do here is first, actually, we needed to really quickly get rid of that 5, right? We don't have a 5 in our function, so we need to go ahead and do that. So we're going to go ahead and pull out a 1/5, and then we know it's an arc sine, so we're going to go ahead and write arc sine. And now, again, I'm going to write the formula here in a second. But the reason I write it, the U's on the top column and then or row, and then A in the second row, is that your function, what you're going to put in parentheses, is right here. It's going to be 5x over 3. All right, it's going to be 5x over 3. So this answer is going to be 1/5 arc sine of 5x plus 3. So let me actually bring this down and show you guys the formula for arc sine. So if you're integrating from 1 over and then the square root of a squared minus u squared du, okay, so whatever this is, then your answer is going to be, and again, it's some number, this is a as a number, u as a function, it's going to be arc sine of u over a plus c. Okay, so you can either write it like this, and you can have it up for you, or you can write it like this. And again, we can have a constant on the outside if when you do u and then du, you have a constant that's not part of the original integration. So that is your formula for this particular example. So again, you're recognizing you have to have a square root, you have to have a negative, you have to have a number here, it has to have a number, minus a function quantity squared. So those are the kind of things you want to look for in order to use the arc sine. All right, now with that being said, this next part should be pretty straightforward. So what is this one going to be? And by the way, if this had been like a negative here, then you would have the arc cosine. All right, so that's the only thing that I want to say about that, is that if this has been a -1, then you would have an arc cosine. So for this one right here, again, if we just look at simplifying this down with all numbers, making it 1, right, making it 1, then I hope that you guys see that this is going to be arc tangent. Okay, arc tangent. Now, the beautiful thing about the arc sine and arc tangent is that initially, the first part is done exactly the same thing as before. All right, there's just one small thing else we have to do with arc tangent, but the rest of this, and I'm just literally copying everything that you see right here. I'm going to keep this purple here, so this is going to be 5 dx. So I'm going to have a 1/5 du equals dx. Okay. Now, guys, sometimes, and I will tell you this, this may be x to the 4th. So you'd have x to the 4th here. You may have an x squared, and then you may have a 2x, right? A 2x here, and then you may see an x right here. So if this had been a 4, this would have an x right here. So again, it's not always going to be this simplistic, but whenever you see 1 over some number plus some quantity squared, arc sine, arc tangent, sorry, is going to be what we probably want to do here. Now, there's one small thing we have to add to arc tangent. So we're going to go ahead and pull out the 1/5, right, which we have right here. But the other thing that we need to do is we need to pull out 1 over a. And I'm going to write that formula for you guys in a second. So we have a is 3, so we also got to pull out a 1/3. So this is the only difference between the two, is that we have to also pull out a 1 over a. And then we're going to go to arc tangent, just like before with the arc sine. So again, these are very awesome that they're very similar in nature. You're going to write this u over a, and you're going to do plus c. So this answer to this problem is going to be 1/15 arc tangent of 5x over 3 plus c. So let us go down here and now write out this one. So the integration of 1 over a squared plus u squared du is going to be equal to 1 over a. 1 over a arc tangent of u over a plus c. And so we want to make sure that we're really good with this, right? 1 over a arc tangent of u over a plus c. So those are our general formulas that you guys are going to use for the next part of our videos. So arc sine, arc tangent, there you go. That's how you do them. And I will see you guys in our next video where we do another couple of different types of integration techniques. So I'll see you guys then.